Good morning. So, in this video, I'm going to explain reduced state table. I mean, construction of reduced state table for the code converter. So, as I explained in the previous video, construction of state table as well as state diagram. From the state table, how do we reduce it? Okay. See, the state table for the code converter is this is the state table. See, it has many states. It has many states. So it is not feasible. So we need to reduce the state table. So we have uh, state reduction rules. State reduction rules. So they are identify the rows having same next state and output. Identify the rows having same next state and outputs. Let's see, and replace them with one row. Replace them with one row. So in that, see, which I have highlighted in the red color, for present state H, next state is AA, output is 0, 1. Again for present state I, next state is AA, output is 0, 1. And here for present state J, next state is A, here don't care, means it can be A, and 0, and don't care, again it can be 1. So H, I, J, K, L are having same next state. So we should say H is equivalent to I, and that is equivalent to J, that is equivalent to K, and that is equivalent to L. Similarly, which I have highlighted in blue color, see, for present state M, next state is A, when x is equal to 0 and when x is equal to 1, don't care. Again, don't care, it can be A. And here it is 1, don't care. Okay. So same next state and output. Same next state for M, N present state. Next state is A, don't care. Output is 1, don't care. So again for P, A, don't care, 1. So we can say M is equivalent to N and that is equivalent to P. Clear now? So replace I, J, K, L with H. I mean retain same rows, no? So retain one row, retain H row and replace wherever I, J, K, L. I mean here I, J, K, L. Replace that with the H. Okay? I, J, K, L. Replace that with the H. If we keep H, so it doesn't mean that we must keep H only. We can keep I also. In that case, we should replace H, J, K, L with the I. Similarly, if we keep M row and replace NP. That means here NP with the M. This NP with the M. Clear na? And remove. Uh, we decided to keep H, remove IJKL row, and we decided to keep M row and remove N and P rows. So when you remove that and replacement happen, this is what the table. Correct? So here H is replaced and M is replaced, and we kept H and M. Clear now? After this again observe the table. See, these three rows are same next state HM 10, HM 10, HM 10. So that means E is equivalent to F and F equivalent to G. So replace F and G with E. I mean this F and J with G and keep E row and remove F and G row. Replace F and G rows. And this is a replace things and this we kept. Clear now? Yeah. So this is what the reduced state table. Reduced state table by applying the state reduction rule, that is replace the row which have the same next state and output for a present state. Clear now? So for this reduced state table, we construct transition table. So construction of transition table for the reduced state table. So here 3 flip-flops are required because total 7 states are there. So minimum 3 flip-flops are required in the reduced state. So here unique combination of flip-flop state must be assigned to each state. I mean for A you need to assign one unique combination of flip-flop state, and for B1, C1 like that. That is unique one. And some assignment will lead economical circuits with few gates, and some other assignment will require many more gates. So in the previous videos, randomly we assigned. So that leads a more gates. So here again we have some rules to be followed. That rules are called as state assignment rules. Assignment rules. So the first rule is using guidelines for state assignment. The first one is states which have same next state for a given input should be adjacent assignment. Should have adjacent assignment. Means states which have same next state for a given input should have adjacent assignment. That means observe state B and C should be adjacent because when input x is equal to 1, next state is E. Same state. State which have same next state for a given input should be adjacent. So for input x is equal to 1, for a present state B and C, next state is same E. So B and C should be adjacent. Similarly, uh, D and E should be adjacent because when x is equal to 0, next state is H, which I have highlighted in the blue color. Similarly, H and M should be adjacent because when x is equal to 0, next state is A. This is the first rule for state assignment. And second one, the states which are the next state of same present state should have adjacent assignment. That means, see, B and C are the states of the same next state A. So first one, B and C should be adjacent because they are of the next state A. Similarly, D, E highlighted in blue color, they have the same next state of B. So B, D and E must be adjacent because they are next state of B. And we are not consider E because they are same state. So here for E present state, H and M are the next state of E. So H and M should be adjacent because they are next state of E. This is the second rule. And the third rule, state which have the same output for a given input should be given adjacent assignment. And this is used for simplification of output function. As the observe, which I have highlighted in the red color, so state A, B, E, M should be adjacent because see when x is equal to 0, A output is 1 for present state B, sorry A for B, E and M output is 1. So when x is equal to 0, output is 1. Similarly, CDH should be adjacent. CDH should be adjacent because for when x is equal to 0, output is 0. When x is equal to 1, output is 1. So when input x is equal to 0, output is 0, and when input x is equal to 1, output is 1. So the states which have the same uh, output for a given input should be adjacent. Clear na? Similarly, states A, B, E should be adjacent since when input x is equal to 1, output is 0 for A, B, E. Okay. This is the third rule, which is mainly used for simplification of output function. So hence, the conclusion is based on the first rule, B should be adjacent to C, and D and E should be adjacent, H and M should be adjacent. For using the second rule also same adjacent. And using third rule, A, B, E, M, all four should be adjacent, and C, D, H and A, B, E should be adjacent. So as you know, we use a K-map. We use a K-map because in the K-map we maintain the physical adjacency of the cells. So we'll construct using a three variable map as an assignment map. See, it is three variable K-map. Okay, two columns represented by one variable, that is Q1 0 1 and Q2 Q3 0 0 0 1 1 1 1 0. Observe here this is A is adjacent to B, and this is adjacent to C, adjacent to D, adjacent to E, and here HM M written. See, first one, B is adjacent to C now. See, B is adjacent to C. Next, D is adjacent to E, and H is adjacent to M. Okay. And third rule, A adjacent to B. Okay, this B is adjacent to E, correct? Because these two cells are adjacent. B is adjacent to E, and E is adjacent to M. E is adjacent to M. So first one is satisfied. And second one, C, D, H should be adjacent. See, C adjacent to D, adjacent to H. And similarly, A adjacent to B, and it is adjacent to E. Okay, na? Third adjacency of third row. Okay, so we maintain all adjacency. Then assignment. See, for A, the values of Q1, Q2, Q3 is 0, 0, 0. And for B, 1, 0, 0. 1, 0, 0. For C, 1, 0, 1. 1, 0, 1. For D, 1, 1, 1. For D, 1, 1, 1. Clear now? So next for E, see 1, 1, 0. For E, 1, 1, 0. And for H, 0, 1, 1, 0, 1, 1. For M, 0, 1, 0, 0, 1, 0. And this is unused. This is unused. That means 0, 0, 1 is unused. You know? So we can now adjacent assignment table as 2 rows and 4 columns. Okay, these are the entries. Here also same adjacency is maintained, and same assignment will be obtained. Clear now? This is how we do assignment. So with this assignment, next we are constructing transition table that I am going to explain in the next video. Thank you.